Today I'm going to present our work entitled Emotion Intensity and Gender Detection via Speech and Facial Expression, which is done in the University of Brussels. In our daily life, we express our emotions in different intensities based on the condition. For example, a polite smile is different in intensity than a spontaneous smile. So, the intensity of expressed emotions is important to be considered in different applications, like human-robot interactions. However, there is not so much work about emotion intensity detection, and most of the previous works have focused on emotion type detection, which is done mostly by analyzing speech and facial features. So, as we used speech and facial features for emotion intensity detection, we used the same approaches as emotion type detection. So, in next slides, I am going to explain you main approaches of emotion type detection by facial and speech features. Facial emotion type recognition can be performed based on facial expression analyzing, which can be done in two different ways. One is feature extraction, which is done by, for example, determining facial landmarks, which means finding the position of different components of face, like nose, mouth corners, eyes corners, eyebrows, and so on. Then finding the distances between these landmarks in different facial expressions. These distances then can be used as features by machine learning models to find the type of expressed emotion. The other way is analyzing facial action units. Each action unit is a muscle or a group of muscles that are activated during expression of a specific emotion. Thereby, by finding the activated muscles in each facial expression, we can determine which emotion is expressed. In this study, we used facial action units activities for emotion intensity detection. The other approach for emotion type recognition is a speech emotion recognition, which is explained in next slides. There are two main approaches for speech emotion type recognition. One is using lexical contents as feature for classification, and the other is using acoustic features. To use lexical contents, we need to first tokenize the text, then identify emotional words, find the intensity of the emotional words, check negations, and finally classifying the type of expressed emotion. The other way is extracting acoustic features like pitch, energy, mel frequency spectrum, and so on, and then giving these features to machine learning classifiers. To find these acoustic features, we first need to break the speech signal into shorter intervals of 30 to 50 milliseconds, and then extracting these features. However, emotional contents are not in static values of these features, but are in their temporal variations. So we use different statistical functions like minimum, maximum, average, and so on to find emotional contents. In this study, we use acoustic features for emotion intensity detection. To train and test our proposed model, we used this dataset, which contains videos of 12 female and 12 males, all North American actresses and actors, expressing 6 basic emotions, which are happiness, surprise, disgust, fear, anger, and sadness. We use this because it provides all 6 basic emotions in 2 scales of low intensity and strong intensity. To obtain facial features, we used an open source toolkit which is OpenFace. OpenFace returns the activity values of 15 different action units in 2 scales of binary and regression, which provide us 13 different features. To obtain speech features, we used another open source toolkit which is OpenEar. OpenEar calculates different acoustic features like MFCC and PCM, which are used in this study. After obtaining the facial and speech features, we designed different deep learning based architectures for the task of emotion intensity detection. Design architectures consist of LSTM, LSTM and attention layer, BiLSTM, BiLSTM and attention layer, and also different combination of convolutional layers with LSTM, BiLSTM and attention layers. Applying the obtained features to the proposed architectures showed that when facial features are used, the combination of convolutional neural networks, BiLSTM and attention layers lead to highest accuracy in compared to the other models. Additionally, the obtained accuracy in emotion intensity detection for males is higher than for females, or the combination of males and females. Using speech features also showed the same model as before obtains the highest accuracy. Interestingly, this time the obtained accuracy in emotion intensity detection for females is higher than for males, or the combination of females and males. In addition, comparing the obtained results with the state of the art showed that the proposed model performs better. As the obtained results for males and females have a noticeable difference, we decided to use the obtained features for the task of gender detection, which again the combination of convolutional layers, BiLSTM and attention layer obtained the best accuracy. Although the proposed model could not obtain the accuracy of the state-of-the-art models, but the obtained accuracy is comparable. And more importantly, as a gender detection model needs to be robust to different emotional states, in this study we considered all 8 emotional states that are provided in RAVE's dataset, while the other works considered less emotional states. For future work, we are going to use the proposed model in a human-robot interaction scenario, where a robot expresses empathic behaviors and needs to know the intensity of the emotional state that the human partner is experiencing. Thank you so much for your attention. Please let me know if you have any comment or any question. You also can contact me via my email address.